Hey guys, welcome back to another episode of the Weekly Coder. We are going to continue on with our 2048 tutorial, and the first thing we are going to cover is, let's get into the game script. So let's go into our scripts folder, and here's that damn pop-up window again. One of these days I'm just going to update Unity and, just be done with it. So in our scripts folder, we are going to open up the game script. Okay, look at that. It's awesome, right? There's like nothing in it. It's ready for us to shape it and make it do what we want it to do. So, the first thing that I like to do is I like to work on the variables that we're going to need. And I like to create those variables before we start doing anything else, because actually we're going to be using those, so we need them there. The first thing that we're going to talk about creating is, and if you guys have watched my previous tutorial, the Tetris one in particular, you'll know that I use a grid matrix to keep track of the tetramino positions throughout the course of the game. So as the minos are falling, there's a grid matrix, a multi-dimensional array, that basically keeps track of the locations, the XY coordinates of each one of those tiles. So this is going to be sort of similar. We're going to create a grid, a multi-dimensional array, that is going to store or basically keep track of the transforms. That's not right. It's not going to keep track of the transforms. It's going to actually store the transforms of the game objects themselves. And then by storing the transforms of the game objects, when we search through our locations in the grid, we'll be able to then extract those and manipulate those. We'll be able to destroy them, we'll be able to merge them to create new tiles, that kind of thing. So the first thing we're going to do is we're going to create a public static integer, and we're going to call it grid width, and we're going to set that equal to 4, and then we're going to create another one and call it grid height, and we're also going to set that equal to 4. Alright, so that will be our grid width and our grid height, and you'll notice that we're working with a 4x4 grid. Okay, so these are the widths, these are our dimensions for a grid. So now we need to create the actual grid array. So we're going to create a static, again, transform, and it's going to be a multi-dimensional array. Okay, and we're going to name it grid, and now we're just going to say new transform, and we're going to specify the width and the height as the size of the array. So we're telling the array, actually let's break this down, okay? So first we're telling it it's going to be a static and it's going to be public, so it's going to be publicly accessible. The next thing we're saying is the type of array that we want to create is a transform array. So that means that this array is going to store transforms, and the comma here basically tells us that we're working with a multi-dimensional array. Here we're giving it a name, so basically we're just giving it, it's like another variable, and we're just calling it grid, right? And here we're initializing this array, this transform array, by specifying the size of the multi-dimensional array. We're giving it 4 in the the first array. The first part of the array is going to be 4, and the second part of the array is going to be 4. So in total, our array is going to be able to hold 16 positions, or 16 indexes for all of our tiles. Alright, so the next thing we should probably do before we get too carried away with anything else is we should probably create that that method that we need for our play button, the play again button. Remember we talked about that last episode, and I said, hey, the first thing I'm going to do is create the play method, and then I was like, nope, and now I've changed my mind again, and we are going to go ahead and create that method. So what we'll do is we'll make it public, which we have to, because remember, if we want to actually have access to something from within the inspector that's in our script, it has to be made public. Okay, that's how we get to things in our scripts from the inspector. So we go public, and we'll make it void because it's not going to return anything, and we'll call this play again. Okay, and we're not going to pass any parameters to it. And the one thing that we're going to want to do is we're going to blank out our grid. All right, that's the only code we're going to put in here for now. We're going to basically just reinitialize our grid with the width and height variables. Okay, we don't really need to put anything else in here for the moment. Now we're going to save that. Okay, Command save is what I pressed, and we're going to head over to the interface really quick. Okay, and we're going to go to the game over canvas. And then in the play again button. Okay, so now if you'll go down here where we've got the on-click event handler list, we'll see the list is empty. What we'll want to do here is click plus, and then next to here, none object. Okay, we need to actually specify an object. So we're going to drag the grid game object. Since the grid game object contains our game class, and in our game class we created a public method called play again, we should be able to go where it says no function, and it should drop down. Okay, and we've got game object, transform, and game. These are the classes. Now we want to work with the game class because that's the one that we created the method in. So now if we go in here, we can see some methods and properties. So we'll just find the play again method that we created and click on that. So anytime someone clicks on that play again button, what'll happen is it'll execute what we've got in our play again method. So before we do anything else, let's go back to Unity real quick and actually save our changes. So we're going to save scenes, save project, and then let's go back to the game class. All right, so we can kind of just avoid this button for now because we've basically constructed the method, so we don't have to go back and interface in the interface designer and change anything at all because it's already been connected. So I like to summarize this, and you do this by actually pressing 3. I don't think I've ever covered this before. So what happens is if you press the / 3 times, it'll create a summary snippet for you, and from here you can kind of it tries its best to come up with a meaningful description, but as you can see here, plays the again. So that's what Unity came up with, but we're going to change that. So we're going to change it to restarts gameplay, and that's it. All right. So what's next? Well, for our game to have any kind of fun factor whatsoever, we need some user input, right? We want the user to be able to press buttons and make things happen. Without that, the game wouldn't be much fun. So let's go ahead and check that, or check. Yeah, we're going to check user input. We're going to go ahead and do that. We're going to create that method. It's also going to return nothing, so it's going to be void. And we're going to check user input. Okay. All right. So that's great, right? We've got a method called check user input. Well, guess what? That method is never going to get called. Even if we put code in it, nothing's ever going to happen. Why? Because these methods are just there. They're there. They can be called, but we're not calling it. So we're going to go into the update method, which is going to get called. It's going to get called 60 times per second, hopefully. And what we do here is we just put check user input. All right, so now our check user input is going to get called as many times as our update method gets called by default. So now what we can do is we can create a check, So I got a new way of doing this, which actually makes things a little simpler. So what we're going to do is we're going to create a boolean, a few booleans, actually 4 of them. And we're going to name them simply down, and then we're going to set that equal to input.getKey, get key down, keycode dot down arrow. All right, and then we're going to do a comma because we're still defining booleans, so we can define all of those on one line. All right, that's just to make things simpler and faster. So then we're going to do up equals input dot get key down. So Sorry for the creaking, guys. I don't know what's going on with my desk. I have to, I don't know, get some oil or something. I don't know. Key code dot up arrow and left equals input dot get key down key code dot left arrow, and then finally let's create a right boolean input dot get key down key code dot right arrow. Okay, so now this may look weird, but what I've just done is I've created 4 variables that are of the same type on one line. I could have simply created them on separate lines, and I could have done bool up, bool left, bool right, and created them on 4 separate lines. But this kind of saves space and kind of makes things look a little more neat, I think. So what we have here then is we are creating the variable and we're initializing it basically right as we're creating it with the value of the return value of the key code that we're requesting here. So like this variable down, at the moment that check user input is called, if the down arrow is being pressed, then this variable will be set to true. Same thing goes for up, left, and right. So now all we have to do is check if down or up or left or right. Okay, so if this is true, or this is true, or this is true, or this is true, that means we've got a key press. Okay, so now all we've got to do is we've got to determine what it is. So if down, okay, then we're going to do something. If up, then we're going to do something else. If left, and we're going to do something else. And if right, and we're going to do something else. Oops, I didn't finish spelling left. Alright. So, and that is not right either. Alright. So, we'll just leave it like that. Alright, so basically, what we've got here, again, we're creating down, up, left, and right booleans. We are setting their values, okay, based on the values of the key code, that of the arrow or of the key that is currently being pressed. And then we are checking to see if any of them are true. And if one of them is true, then we check which one is. And then once we find which one is, we're going to execute the code in between these brackets that we have yet to write. Okay. So that's good, right? Now we've got our check user input. We don't have any code in here yet. We're going to move on to that in a little bit. Actually, probably in another tutorial. But what I would like to talk about next, as we move on, is the next method that we're going to create. So, we're going to create a fun one. This is going to be basically used for the getting locations for placing tiles. So, we don't want to always start out with, well, we always want to start out with at least 2 tiles, right? That's the one thing we know. We need at least 2 tiles every time we start the game. Those 2 tiles have to be matching values. Because if we get a 2 and a 4, the game is over. Because we can't match them, and no new tiles will be generated because we haven't matched any tiles. Wrong. That's a wrong statement, actually. We can have a 2 and a 4 because every time you move, a new tile is generated. Not only when tiles are merged, but any time you move. Okay? So remember that. The rules of this game right now, we need at least 2 tiles when the game starts. They can be a 2 or a 4. I prefer to just have 2 2s all the time. Every time the game starts, I'll make 2 2s. Just because. They should be random locations. Okay, we don't want our two tiles to always start in the same spot. Not to mention, when we bring in new tiles, a random location needs to be chosen based on the available tiles that we have to play with. Okay, so let's say the top right, that would be on your side, would be over here, right? I think, anyways. So the top row is taken. So we need some way of figuring out, okay, we've got all these spaces down here. We need to pick a space from one of those spaces. That's what this method that we're about to create is going to be for. All right. So we're going to call it get random location for new tile, and it's going to return a vector 2. Get random location for new tile. We're not going to pass in any parameters, okay? But now, right now, the method is underlined with a red line because basically it's just telling us that it doesn't return anything. We've told it that it's going to return a vector 2, but it's not returning anything. So basically, right now, this would yield us with an error when we tried to start the game because our method isn't returning anything. So now, what we need to do is we need to figure out how what the best way is of actually creating this system of finding locations of tiles or blank spaces for tiles and storing them and then returning that location. So basically what I'm going to do is I'm going to create, because so what we need to do is we need to actually store all of the empty locations that we have available. Okay, so it's not just about finding the first available location, it's about storing them all and then picking a random one from it. Otherwise, you're always going to find that first square and it's going to look very repetitive versus having a list of all of the available spaces and picking one randomly from there. So first we have to find all the availables. We have to store them. And then after that, we have to pick a random location from that stored location. So what we're going to do is we're going to create two lists. Okay? These two lists, one list is going to hold all the X positions and one list is going to hold all the Y positions. So first thing we'll do is we'll start off with list. And these lists are going to be integers. And you can think of lists as kind of like an array. That basically stores values. What did I do here? That's not right. Okay. And we're going to do list int y new list. And okay. So that's how we create a list and initialize it with a type. Okay, so this list is going to basically store types, or these lists are going to be of type integers. So they're going to store integer values in their locations. So the next thing we need to do is we need to iterate over our grid. So we're going to do for, I'm going to create a for loop, int, we're going to do j equals 0, and j is less than grid width. And then we're going to do j++ to increment, right? So then here, we're going to do for int I equals 0, I is less than grid height, and I++. Alright. So what it's going to do is it's going to start at 0, and then in the for loop, it's going to run another for loop, and it's going to basically iterate over all of the y positions of the grid. So it's going to start at 0, then go to 1, then go to 2, and go to 3. And then once it's done with that, then this for loop is going to go to its next iteration. It's going to go to position 1 on the x-axis. And then it's going to go over this again. I, 0, 1, 2, 3. And then next, and then next, and then next. And that's how it's going to work. So next we need to know if the space that we're in is going to be empty. Right? So we just do if grid. We're going to get the item. Right? We're not going to actually get the item. We're just going to check to see if that space is null. Because we're storing transforms in our grid array, we basically just pass in the x and y, value, okay, so x and y coordinate of our multidimensional array. We're going to say x. So right now, this is 0 and 0. So we're saying grid, if there's a transform, or if the index 0, 0 in the grid array is null, that means that we haven't assigned a transform to it, okay? Then we're going to add j, and we're going to add y. Not y, I, sorry. We're going to add I as y. Alright, so j, this is why I couldn't use x and y for our arrays, or for our iterations for the for loops, because we've already used x and y for the list. So j represents x, I represents y. So when we find a spot in our array that doesn't have a transform assigned to it, we basically take those values and we add them to the x and y lists. And we keep doing that all the way until we iterate over the entire loop, or the entire grid. We are then going to create an integer random index, okay? And we're going to use random, which is a class. We're going to use a method called range, and we're going to specify 0 as the minimum and x.count as the maximum. All right, so now x.count is the list, okay, the list x, which has just as many items as y. We're going to count how many items there are, which based on this, so let's say that we have 5 spaces available, it finds those 5 spaces, adds them, okay, those locations. That means that now we have 5 spaces in here, okay, so that means 5. So the range that we're going to get is between 0 and 5. So now what we need to do is we need to get random coordinates, okay, so we do int rand x equals x dot element, can't do element at because we need to include a namespace. So here's what we're going to do. We're going to go up here to the top, and we're going to say using system.link. That's going to add the system.link namespace to our project so that we can use the element at method on the list class. So I'm going to do int rand x equals x dot element at, and then we're just going to specify a random index, and int rand y equals y dot element at and rand index. Okay. And now we're just going to return new vector2 rand x rand y. Okay. So what this looks probably, if I would have shown you this before explaining anything, this probably would have just looked a little confusing, because there's a lot going on here, and a little, right? And in a little amount of space, we're doing actually quite a lot of work. So the reason that we're using lists as opposed to arrays is because we don't know how large the list is going to be. We don't know how many spaces there are going to be, because the array needs an initializer to tell us how big the array is going to be. We use a list and just keep adding to that list until we're done. So here we're initializing the new list. We've got our for loops iterating over the grid. We're adding every time we don't find a transform assigned to a spot in the grid. We then generate a random integer between the amount of items that are in the list and 0. And then we are taking that random index. So we're getting the value that we stored in the list. Okay. The index basically just is that random number that we generated right here. Okay? So, and we're using that in the X list and the Y list so that we get the actual X and Y coordinate of our new tile. And then we're just returning that. Okay? So at this point, what I want to do is I want to actually just do some testing to see if our get random location for new tile actually works. All right? And for that, I'm actually going to introduce you guys to a little class that I wrote, which is actually quite helpful. I know a lot of you probably, or some of you, are used to the debug command, debug.log, which basically outputs text or whatever you want into the console to help you debug things. I like to go one step further and make my debug log actually look nice. So I like to use what's called OnGUI, which is something that Unity has available to you that used to be the main sort of like menu building before they came out with UI stuff. This is what was used. It was OnGUI. They had buttons, they had labels, and all kinds of other stuff. Now I think it's mostly used for debugging. I use it for debugging as a kind of a visual aid. So instead of writing debug.log, for instance here in our check user input, if we wanted to, we could go in here and we could write debug.log player pressed down. So what this would do is this would output into the console the player pressed down. And it would just keep appending to the console and keep going and going and going and going and going until you have thousands of log entries that you have to sift through to see what's going on. I kind of just like to know if the player is currently pressing up, down, left, or right, because that's all I care about. Is he currently doing it? That's what was the last button he pressed. That's all I care about. Same thing with this. We want to know, hey, did we generate? What was the new location that we generated? Do we want that in our log, in our console, with all the other stuff that's mixed in, and have to kind of just scroll through it to find it? I don't know. I don't like it. So I created a class. So let's get to that. I have it in. You guys can download it. It'll be in a link below, and it's called CFDebug. So what we're going to do is we're going to go to Unity, and in the scripts, we're just going to drag that in, CFDebug. And you don't have to use this if you don't want, but I'm going to show you how to do it anyways, just in case you want to. So in the hierarchy, we're going to create an empty. We'll just call this debug. And in the empty, we're going to drag the CFDebug class. You can keep all the defaults, or you can play around with them. I'll show you how to do that in just a few after we get into this. Right? So now what we want to do is we want to go back to our, actually let's save this. Save project, save scenes. Now we're going to go to our game script. And at the top here, where we've got our variables, we're going to do a private, because it doesn't need to be publicly accessible. And we're going to do CFDebug, and we'll just call it debug. Okay. So now all we have to do is debug.add. Alright, and that takes 3 variables. Alright, so it's going to take a description. So player pressed button, or player pressed key. And the next value is, or the next string is going to be the value, right? What we're interested in seeing. So here we can just write down. And then we want a label. And this, what this is for, this is kind of groups your messages together. So let's just say check user input. That's what we'll call it. Okay. So now I'm going to copy this, and I'm going to paste it into here, into here, and into here. And here we're just going to change down to up. And left and right. Okay. So notice how I've got check user input as my label. That's going to group all of these together so that when this gets shown on the screen, we will only ever see one of these, and it'll either be down, up, left, or right. Okay. And for the same thing here, get random location for new tile. So what we'll do is, once we find our random index, okay, we'll want to know if that actually produced something usable. So we'll do debug.add, and then let's just call it new random tile location. And then the value is going to be after we assign it here. Okay. So the value is going to be then rand x, and then we'll add in a comma and rand y. And then we will call this one random location. Semicolon at the end. Alright, and then one other thing I like to do is I like to actually keep track of my game timer. So we can do that here. So we'll just do another debug.add. And we'll just do current time. And then we'll do the value for that is time.time. And we'll just call this current time. Alright. Time.time.toString, because we have to use strings here. That's how I set this up. Alright, so we'll save it. And let's go into Unity. Okay, so one thing we've got to do is we've actually got to go to our grid game class. And before we do that, we're going to have to go back. And we're going to have to make this public. Alright. Because we have to access it from the inspector. So we're going to go back to grid. And then in our game script, we've got a debug property. We're just going to assign the debug object. Alright, so now when we press play, alright, the first thing that happens is we've got our current time. Alright, so now if we press left, right, up, or down, so we press left, up, down, right, see that? Okay, so now we can keep track of what buttons we've pressed. So now, if we also want to show our random location that we're generating, we can do that by just calling that from like one of our key presses. So if we go in and we press down, we can call get random location for new tile, and that should trigger this debug message to add to our debug stack and show us what the random location is that it found. Okay, so I'll save that. And we'll press play. Okay. Again, we've got our current time. We press left, up, nothing, right, nothing, down, and now we've got a random location. Now if we press down again, it shows us a new random location, another random location. I pressed up, down, down. See how we keep getting new random locations, and it's, you know, pretty sporadic with the locations because our grid is always empty, but it always finds a random location, which is cool, right? Because that's what we need in order to pop up our tiles. And like I said, you don't have to use this as a debugging method, but I kind of like it because it shows me everything that I need while I'm developing this game. So with that, I'm going to continue to use this throughout the tutorial. Like I said, you're welcome to if you want. If not, that's up to you. I'm just going to go through some of the settings really quick in these debug class. So one thing you can do is you can change the font color of the text to whatever looks good for you. All right. Blue is pretty cool, but like a lighter blue, like that. All right, that's kind of cool. We can also change the font size. So if you have a hard time reading this, you can do that. And of course, if you change the font size, you're going to want to change the horizontal spacing for the labels. And there you go. Or if you want a really small font size, you can do that too. You can also change the vertical spacing between your labels. You can change your starting location, so where you want your things to start at. I'll go back to 10. Let's see what else. Horizontal spacing is this. Then we've got label height. That's how high your labels are, and depending on what font you choose, you're going to have to adjust this. Let's see what else. The padding is how far from left, top, and bottom your labels are from the box. You can also choose to show the box or not. I like the box. The box looks cool. Other than that, that's pretty much it. So yeah, I'm going to just play around with this here for a second and put it back to where I had it. And we have 40 for the padding, and that's it. And we'll go back to our white font. Okay, so yeah, here we go. Up, left, right, down, 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 down. Okay. That's it for this tutorial. The next tutorial, we are going to actually generate tiles at the beginning of the game. We're going to generate tiles, and maybe we will get into moving the tiles as well. That'll be fun. So this tutorial wasn't too much fun, but it is getting us a step closer to having a working game. So hopefully you guys enjoy that, and I will see you next time. Don't forget to subscribe. Give me a thumbs up if you like the video. Don't forget to click the bell. I know it's there now, so don't forget to click it. And don't forget to give me a thumbs up. Share my videos, because they're cool. See you guys later.